Hi guys, happy Friday. I've got my traditional science club shirt on. It's just not the same without being in the class, so hopefully we'll be back there soon. Today's bell ringers are what is brass, post question, and then I need you to tell me the solvent and the solute in the following solutions. Hydrochloric acid. Remember, all acids are in water. Okay, magnesium hydroxide, calcium chloride, and nitric acid. Again, keep your bell ringers in your notebook, and we will look at them when we get back. So, this demo is much better in person, but we're going to have to make do. In this case, I can show you how conductive solutions are. If we have a strong electrolyte and we put electrodes in both sides, you're going to see a really bright glow of a light bulb. Strong electrolytes dissociate into ions completely, so there's a lot of positive and negative charges, so it's kind of like a full strength battery, if you will. Examples of strong electrolytes are included below, but salt water is the one I usually use for this demonstration for obvious reasons. I don't want to use hydrochloric acid or drain cleaner on the front lab table. Weak electrolytes like tap water make a very weak glow, and you can see the bulb will be about half lit, and they don't dissociate completely. Water will break into hydrogen and OH on its own, and there's a few ions in tap water, but without it being salt water, it's not a strong electrolyte. Vinegar is also a weak electrolyte. Things that are non-electrolytes like sugar and water. Sugar doesn't have, it's not polar. Alcohol and oils, those would have no electricity going through them at all. Okay, we have three types of mixtures that I want to talk about, and these are just terms that I think you might or might not have been introduced to. So one is a suspension. The second type of mixture is a colloid. And the third is a true solution. A characteristic that distinguishes one type from the other is the particle size. So suspensions, that's like, if you've ever looked at the Embrow River, that's pretty much a suspension. There's a lot of sludge, there's a lot of large particles suspended in that water. That's why it's murky and you can't see through it. That's a suspension. Suspensions can be filtered out with filter paper, and they will also settle out by gravity. So if you went down to the Embrow River and scooped up a little bit of the water and sat it for a while, you would see that all the sand and suspensions would settle out. These particles will also scatter if light shine through them. So again, the classic example, is muddy water or sand mixed with water. Here's another example of a suspension. If you've got sand and water, which is silicon dioxide, you can see that it will float around in the water. It's how a lot of soils are moved through. Vinegar and oil salad dressing is a suspension. There are lots of herbs and other things floating around in there, and you can clearly see what a suspension looks like here. Okay. Colloids are particles that are much smaller in size. You can't really see them, and they can't be filtered by ordinary means. They don't just settle out, and they're not really big enough to scatter a beam of light. So some examples would be milk, mayonnaise, gelatin, paint, fog, and air. Colloidal gold and colloidal silver, the particles range from 1 nanometer to 1,000 nanometers, and they can have a very unique effect. The different sizes of colloidal gold particles are shown here, and they can arrange for the viewing and give you an illusion of different colors based on just their nanoparticles. that is actually utilized in stained glass and has been used for eons, as the stained glass artist mix the paints and the opaques that get painted on that glass. Okay, true solutions. They have particles so small that they can't be filtered, they don't settle out, they don't scatter beam the light, they don't look in different colors. True solutions would be air, brass, sugar and water, and salt water. So just to give you another overview to look at these three types, you've got suspensions, colloids, and solutions. And to bring back some of the old terminology, heterogeneous means it looks different throughout, like Chex Mix. Homogeneous, like milk, looks the same throughout. Large particles are found in suspensions. Examples would be muddy water. Colloids have very small particles. Examples would be milk, jello, clouds, fog. Again, you have subatomic particles, ions, dissolved. You're going to have to get it out by another mean like distillation or other things. Metal alloys, air, salt water would be examples of homogeneous mixtures or solutions. And that's all for this Friday. Hope you guys had a great week, and I look forward to more for next week.